Hello everyone, my name is Ray, who is in charge of the technical service. Today, I'm going to introduce you the wireless LAN essentials. To start this course, please learn the Ethernet essentials first. Some idea of wireless is similar or same as Ethernet. This course is open for all the technical service engineers. This lesson is going to introduce the Wi-Fi essential knowledge that a technical service engineer should know before learning Mozart Wi-Fi products. In this lesson, you will learn the basic knowledge of wireless technology, and we will focus on IEEE 802.11, the Wi-Fi technology. This is today's agenda. First, I will tell you why users consider to use wireless devices. Second, is the history of IEEE 802.11. The third part is the Wi-Fi essentials. We will base on OSI 7-layer model to learn this technology, and I will introduce it from physical layer to max sublayer. Let's start it. Why wireless? Please take a look of this photo. You may see what a mess. There are so many cables you need to use to connect all the network devices. If you just connect them without any plan, it may look like this. If you have planned to arrange the cables, it could look like the second photo. It looks more clear, but still a lot of cables. Do the cables be necessary? It occupies so many rooms and so many costs. Could we remove the cables? Yes, we can. Try wireless technology. As we learned in the course Ethernet Essentials, the wired network is separated to several categories by the coverage, and so does wireless network. The wireless wide area network can cover around 1 km² area. For wireless local area network, maybe 100 meters square area, and for wireless personal area network is around 10 meters square area. From wireless PAN to wireless WAN, there are several popular technologies. The Bluetooth, Zigbee, and infrared networking only covers 10 meters square area. The IEEE 802.11 ABGN is the technology of wireless WAN which will be focused on this course. For wireless WAN, the second G, 2.5G, 3G, or maybe 4G is the most famous one, which is used on your cell phone. For the following slides, let's talk more details about the IEEE 802.11 ABGN, which also called Wi-Fi. The IEEE 802.11 implements wireless LAN computer communication in the 2.4, 3.7, 5, and 60 GHz frequency bands since 1997. At first, 11A is only focusing on frequency 5 GHz, and 11B is on 2.4 GHz in 1999. 11G increases the data rate to 54 megabits per second in 2003. 11N increased it up to 600 megabits per second in 2009 on both 2.4 and 5 GHz of the frequency. Let's start the Wi-Fi essentials, the major parts of this lesson today. The IEEE 802.11 only defines the physical layer and the max sublayer of this technology. For the physical layer, it defines which frequency should be used and the modulation. For max sublayer, it defines how to transmit data from one node to another. And from next slide, I will explain it from physical layer to max sublayer. The first key point of physical layer is the frequency it uses. For 11BGN, it uses the band of 2.4 GHz. It's free worldwide, so most channels can be used for every country in the world. For 11A, it uses 5 GHz. Since every country may only allow some of the channels to be used by customer, which channels can be used is according to different countries' law. A user may need to configure it while using a 11A Wi-Fi device. As you know, the wireless communication is between two wireless devices. The sender side transmits data, and the receiver side will receive data. At the sender side, how much energy could it use to transmit data out? If it can use more energy, the transmit distance will be longer. And how big is it? We call this transmit power, and you can see it on the datasheet or the specification of any Wi-Fi devices. Another key spec is receiver sensitivity. For the receiver side, a wireless device should recognize the data from sender side. How low energy could it be recognized? It's called receiver sensitivity. If it's lower, it means the device is more sensitive. A wireless device should have at least one antenna for it to transmit or receive wireless signals. If it has two, most on an access point, it may have a function which is called antenna diversity, to choose which antenna may be used to transmit data. When set to auto, it will automatically switch to the one which has better signal. For AO2.11n devices, there is a new technology, MIMO, multi-input, multi-output. For example, if there are two antennas, the data can be separated to two parts and transmitted by two different antennas to the receiver side simultaneously. And the receiver will combine them together. In this case, the data rate can be doubled by this technology. Channel bonding is also a new technology for AO2.11n. In the past, when transmitting data, it only uses one channel. For 11n, it can use two channels at the same time. Similar to MIMO, it separates the data and transmits them via two channels simultaneously, and this also doubles the data rate. You may still remember that I introduced you the CSMA-CD in the course, Ethernet Essentials. Why not use the same technology here? The collision detection wastes transmission capacity, and AO2.11 uses collision avoid instead. Before a node starting transmission, it detects the current channel and see if it's clear. If yes, start sending. If no, back off and wait for a random time. The flowchart will be like this. When a node wants to transmit data, it may assemble the frame first, then listen if the channel is idle or not. If no, wait for a random backoff time. If yes, transmit a very small packet RTS to the target node. In most cases, it may be an access point, and then wait. The AP will respond the CTS to the sender and also inform other nodes that there is a node going to transmit data. When the sender receives the CTS, it knows it can start to transmit application data. On the left-hand side of this slide, you can see all devices in the blue area can hear the radio signals, especially the CTS from AP. So, before starting their transmission, devices will have the CSMA/CA check. After laying the physical layer and the mixed-up layer of AO 2.11, there are some key words about it before talking about a Wi-Fi network. As you can see in the slide, any devices with AO 2.11 ability is called station, such as a laptop. And wireless NPort belong to a mobile station. The BSS, Basic Service Set, is a set of stations controlled by a single coordination function. So, several stations with an AP can form a single BSS unit. Communications take place within an area called the Basic Service Area. When a station is in the Basic Service Area, it can communicate with the other members of the BSS. Access point can connect one BSS to wired network and centralize coordination for BSS. A set of BSSs is called create coverage in small office and homes, but they cannot provide network coverage to larger areas. AO 2.11 allows wireless networks of arbitrarily large size to be created by linking BSS into an extended service set (ESS) via a distribution system. In typical installations, the DS is simply the existing IP network infrastructure like Ethernet, fiber, or even the radio wave. So, an ESS is created by chaining several BSS together with a backbone network. There are two different modes of operation for AO 2.11 devices: ad hoc or infrastructure mode. An ad hoc network is usually one that exists between two or more wireless devices that is connected without any access point. We also call it as an independent basic service set, which is a set of stations with no coordination function. Typically, IBSS are composed of a small number of stations set up for a specific purpose and for a short period of time. For example, two laptop users wishing to share files so they could set up an ad hoc network and share files over the wireless media directly. Infrastructure mode assumes the presence of one or more APs bridging the wireless media to the wired media. The AP handles station authentication and association to the wireless network. All mobile stations are required to reach each other only through the access point. Then AP will forward all data to correct destination. Next, we are going to introduce how a client connects to AP. When a client is going to connect to an AP, there are three steps. First, it will scan the BSS to have the AP list and find an AP that it would like to connect. Then it will start authentication with the AP to establish the wireless connection. When it finishes, the client is connected to the AP already. After authentication, it goes to association process. The client needs to send the username and password to AP for verifying if this user has the authority to access the network, mostly wired network. If not, it will be rejected to access this network. When it passes the association, the client can start to communicate with the AP. Since the client established a wireless connection to the AP, the client may be removable. For example, an automated guided vehicle. Because it's movable, it may not just connect to only one AP. It could change to the second AP when it moves from A to B. And the technology for it to move is called roaming. After today's introduction, there are 4 things to remember. First, Wi-Fi includes 802.11 ABGN. 11AN uses the frequency of 5 GHz, and 11BGN uses 2.4 GHz. The second thing is there are 2 types of wireless network, ad hoc and infrastructure. And the third thing is a wireless client needs to pass authentication and association process to connect to a network via an AP. The last thing is the roaming. It means a wireless client changes from one AP to another. Thank you for your time, and the Wi-Fi Essentials finishes here.